Hello, welcome back. True to word here, we're going to start. As a reminder, please do squish in as you can to make room for others. So if you can sort of move to the center to leave that space, that'll be great. If you are interested in the topic tables, we're going to be selecting the topic tables for lunch here in a few minutes. You can go to g.co/GTAC2013 and you can find a link to the moderator to go and figure out what topics you want to vote up or vote down or even suggest a new topic. So please go do that right now if you can. And up next here, we have David Burns and Malini from Mozilla here that are going to talk about how do you test a mobile OS. And a little fact about Malini here. She told me that her dog is named after a test subject in Portal. So you can always go ask her about this from that. So with that, I'll let them kick it off. Thank you.
Thank you. So can you all hear me okay? Yeah, awesome. So I'm Malini Das, and this is David Burns. And we work on automation frameworks over at Mozilla. And we're here today to give you a rundown of the recent challenges that Mozilla has been facing while automating a new mobile OS. So how do you test a mobile OS? That's the question that first came into our heads when we were tasked with supporting this new platform. And we knew that answering this question wasn't going to be as easy as just Googling for an answer or just winging it as we went along. There's a depth of problems that need solving, and solving them in a good and long-lasting way would save us lots of pain in the future. So today, David and I are going to talk to you about how we solve this complex problem and share with you the pain points and the victories we had along the way. So let's see here. Great. So what mobile OS am I talking about? As some of you might know, Mozilla has been working on something called Firefox OS. And this is an open, web-accessible device that's built on top of what we know best, which is the browser. So we're using Gecko, which is our web rendering engine, to drive the phone itself, allowing all the applications running on our phone to be written in CSS, JavaScript, and HTML5. So now you might be wondering, why would we want that in a phone? Well, we've seen a recent trend towards web technologies in the mobile environment. So around 60% of the apps right now in Google Play and the App Store have at least one part of the app that's a web view. So what this means is that on top of your operating system that needs to run your native applications, you also need to have a web rendering engine just to show this web view. And this trend towards web views isn't going to go away anytime soon. We're seeing a prevalence of frameworks like PhoneGap, which allow you to write an application once using web technologies and deploy to multiple mobile platforms instantaneously. So what's the problem here? The problem is that these operating systems are doing extra work. So not only are they running native applications, but they also need to run a web rendering engine just to show you parts of this application. So is there a way to remove this extra work? That's the goal of Firefox OS. What we want to do is unite the concerns of the OS and the browser so your phone is doing less work. And what we want to do is optimize it so well that we can run on low-end devices. So we get this benefit that by optimizing our browser, we get to optimize our phone. And by targeting low-end devices, we get to put this phone out to emerging markets and put it in the hands of people who may not have a smartphone before or may not have had access to the internet before. So what this means is we now have to make our browser a phone. And what is that? What do we need to do for that? That means that our browser has to do things like send SMSs and make phone calls. And on top of that, it has to act like a browser, so it has to render web pages. And that gave us, the automation and tools team, the task of figuring out how we can instrument and test all these new features in this platform. So what exactly should we test? Since Firefox OS is essentially a flavor of Firefox, but on the phone, we want to test all the same parts. So this means that we want to test things like rendering. Now, rendering essentially means how the web page looks like once it's loaded. And the way that we test it is that we let the web page load, and we compare the data with either a reference image or reference data to make sure that they match. If they don't match, then we're not giving new mobile users an experience of the mobile web that they deserve. We don't want to regress in any way in rendering. Another shared another shared concern that we have with browsers is that we want to make sure that we have a performant phone. So we need to check performance. If our phone takes too long to execute anything, then no one's going to want to use this phone. So this means that we need to test performance for simple things like loading an application, but we also want to do stress tests so that we can make sure that we don't provide a degraded experience over time, or that we can catch memory leaks and all that fun stuff. But now, on top of these concerns that we have with our browser, we have new concerns since we're a smartphone. We now have to worry about application unit and integration tests. So smartphones have like a number of base applications, like the calendar or the dialer. And you want to make sure that these applications work before you send out this phone to people. So to do that, you want to answer questions like, does my application work? Do the functional parts of this application work? Does this application work with the system app? Does it work while other applications are running in the background? Now, this is important for us so that we can test our own base applications. But we also want to give this test framework to third-party developers so that when they write their apps, they can have the confidence that it'll work in this new environment. So Firefox OS is not just going to run on any desktop. It's going to run on phones. So now we have to worry about testing the phone environment itself. This means things like gathering hardware metrics. So one of the hardware metrics that we want to gather is things like boot time. So how long it takes the phone from an off state to go into a usable state. Like, I'm sure we all had phones at some point where you could press the button to turn it on, and it's just not responding. So you go and you make a coffee, and you come back, and you still see a boot screen. Like, that behavior is not acceptable for new users. It might be OK for early adopter types, but we're going to be giving this phone to people who may never have had a phone before, and we want to give them a good and optimized experience. So as we develop this phone, we want to make sure that we can gather data like boot time and make sure that we don't regress. Another important thing that we need to worry about now that we're running on a phone is hardware metrics as the phone is running. So things like battery life. Like back when we all had feature phones, you could turn our phone on, it would run for a week without having to recharge it. But now with our energy guzzling smartphones, we're lucky to get 2 days off a single charge. So we want to be able to make sure that as we progress with our phone and as we build it out, we maintain a good battery life and other hardware metrics like this. Now, one of our most important and interesting new test concerns is telephony. So the smartphone has to be able to do things like send a text message and check your network provider and make an actual phone call. And if you can't do this reliably, then it's nothing more than a frustrating portable computer. So we're going to have to figure out how we can actually solve for testing telephony. So now that we know what we want to test in general, how do we go about doing that? Do we have any tech lying around that can help us run tests for these concerns? Well, since Firefox OS is similar to Firefox, then we can use the tests that we run against Firefox against it. We have many existing frameworks for Firefox, but none of them tackle all of the issues that we need to tackle here. We have things for rendering and performance, but we don't have things for telephony. We don't have a way of communicating to multiple instances at the same time because we never had to deal with cross-device communication. So what all this pointed out to was that we needed a new framework. And us being good engineers, we were wondering, wait, we shouldn't just let this be a Band-Aid solution. We have the opportunity to build a framework that can answer questions not only for now, but can build for the future so that any future framework that we build can leverage the work that we're doing now. So now that we figured out, OK, we need a new framework, what exactly should it solve? So this framework has to support our existing test frameworks. So Mozilla has hundreds of thousands of tests running against Firefox. And we want to be able to seamlessly run them against Firefox OS. It makes no sense to go off and make your own framework and then rewrite all the tests. Like, that's just madness and unnecessary work. So the ideal framework will be able to uplift all these frameworks into Firefox OS. The next requirement is that it should be the foundation for future frameworks. What this means is that to run any tests on the phone, we need to be able to communicate with that phone. So the test runner has to talk to the test device. And this is the core driving mechanism behind all of our frameworks. And any future framework will need to solve for this communication. So our framework should be able to provide this core pipework that's reusable across frameworks today and tomorrow. And the last requirement is that it should be reusable for any Gecko environment. So what that means is that whatever we create today should work on Firefox for Android, Firefox for Desktop, and Firefox OS, and any Gecko product in the future. This will help us write one test framework once and then easily run them in any other environment later. So let's get to the gritty details of these requirements. So in order to uplift some of our existing frameworks, what do we need to do? Well, our existing frameworks currently rely on Firefox add-ons to run. They use add-ons so that they have access to the privileged to the privileged space of your test environment. So they execute code against the Chrome of the environment. And this is fine for desktop because it has the ability to run Firefox add-ons. But in the beginning days of Firefox OS, we didn't have the ability to run add-ons. We first started thinking about test solutions about 4 months after the project was announced. So we had very little to work with. We didn't know what direction the product will eventually go in. But all we knew is that we're going to be building this on top of Gecko. So while we didn't have the ability to easily uplift these frameworks using add-ons, that means that we have to somehow integrate our framework with Gecko itself. This was actually an opportunity because instead of running as an add-on, we now get to integrate directly into the engine and we would get a performance boost. So whatever we select as our framework, we have to make sure that we integrate the key parts for every framework so that they'll be uplifted easily without any problems. Another consideration that we need to take into account is that we're running on phones, and we don't want to assume that the phone will always be connected to a computer via USB. We want to stick them in data centers and somehow talk to them over the network. So whatever framework we have, we want it to be able to work in a networked environment so that we can remotely communicate with other devices. And the last but extremely important consideration is what can we actually open up on the phone? So we don't want to just test web views. We want to be able to test things like setting the battery and check if the web view has actually received this new information. We want to be able to get as much control on the device as possible from the get-go. So what can we actually control? So what this all boils down to is we need a reusable and easy way to control all different phones and to control multiple devices at the same time. And all of this should be done in an easy and reusable manner across frameworks. We want to drive the phone at all layers, and we want to have privileges across the device. So what that means is that I want to be able to change file permissions, but I also want to be able to do things like change app permissions. So the solution that we came up with is a framework that we called Marionette, which is essentially WebDriver meets Firefox OS. So why WebDriver? Well, the phone itself is a web device. So WebDriver was written so that you can manipulate user views from a user perspective, so you can test web pages in an easy and supported manner. The great thing about WebDriver is that it's the protocol behind Selenium. So by implementing WebDriver, we get to uplift our existing Selenium tests for free. And it's something that's already familiar to testers. On top of that, WebDriver is being proposed as the W3C standard for browser automation. So by implementing WebDriver, we essentially get to kill 2 birds with 1 stone because we can implement open web standards and also solve our testing needs. Another great thing about WebDriver is that it solves our remote access problem for free. It's already built in with the idea of local and remote ends, so you can communicate and create a session, a WebDriver session, with one device, and then also have another session with another device within the same test. So this will allow us to do things like cross-device telephony. And the other thing, other consideration is how will this help us with our uplifting frameworks problem? Well, WebDriver has this extremely helpful method called execute script. And what execute script does is that, yeah, you know what it does. It's totally hacky, but it's awesome because it works exactly what we need to do. What it does is that it lets you execute any arbitrary JavaScript that you want in the current application space. And that's exactly what Firefox add-ons were trying to do. We use them only to execute code on the device itself. But, as I mentioned before, we needed to execute code in privileged space, that is the Chrome, and WebDriver only cares about content, so what the user sees. So what we ended up doing is we didn't end up making WebDriver itself, we ended up doing WebDriver++, so we added a few extra things to it. So we needed to access privileged space, so we added a new method called setContext. And what setContext does is that it allows you to to set the current executing context of your Selenium commands. So you can do things like, I'm going to set the context to content, I'm going to navigate to a web page, and I'm going to check what privileges this web page has. Then I'm going to set the context to Chrome, change the application permissions, and then go back into the content and check if my application has actually respected these permission changes. So this helps us write extremely robust tests, but it also helps us uplift these frameworks for free because now they can easily execute whatever JavaScript they want against the Chrome. Another key difference that our WebDriver implementation has is that the current WebDriver implementation doesn't have a full spec'd out area on gestures. And we're a phone, and we have a touchscreen, so that means that we want to automate user input, which is multi-finger gestures. So just to get our own work off the ground, we started working on the WebDriver specification for gestures. And what this means is that we added a bunch of gesture commands into our implementation. But the general way that we solved it is that we added the ability for you to create any gesture you want using chains of action primitives. So that is like I can chain one finger to do press, move, and release, but the other finger can just press and release. And then you can chain these things together to create any gesture you need. And the third difference that this implementation of WebDriver has to other ones in Firefox is that it's built directly into Gecko. And that gave us a huge performance boost because you're no longer running as some secondary concern, you're a primary concern. So to explain the gritty details of its implementation is David Burns. There you
go. So how does it all work? As Malini said, Marionette gets kicked off every time Gecko starts up. And so Gecko starts up every time the browser starts up. And we have this really nice server sitting there waiting for us to now accept commands and execute them. And because it's essentially just executing JavaScript and like large portions of Firefox is written in JavaScript, we can now call pretty much anything. We can go all the way, as Malini said, from the browser Chrome, which is kind of where all the nice security areas are, down to the very insecure parts, which is a web page. And we can execute anything in between. So now we're essentially starting to drive a phone, an operating system with WebDriver, a standards-based automation API, just driving an operating system. It pretty much doesn't get any cooler than that. So I'm going to now split it out into kind of how we did things. We've done a number of things slightly different to the way the WebDriver project does things. And it's mainly because it's what fits better with us. So we essentially have a dummy client which just kind of sends arbitrary commands over to the device. The WebDriver project kind of does things with HTTP. Its protocol is kind of REST-ish. It's not proper REST, but it's close enough. And it delivers a nice JSON payload into a browser. Browser then knows what to do with it. And because we're doing things with a JSON packet, and we're doing raw sockets into the device, we only allow one connection. And the reason why we're doing it with pure TCP is because we're trying to utilize some of the other technologies that are going into Gecko at the moment, like the remote debugger. We're using a similar technology, but I'll get back to that. It's in the server part. So I'll kind of show you how, from a simple point of view, I'm just going to use the terminal. We can easily just kind of telnet into the device. I don't know if anyone can see that. No. Hello. OK. I'll leave it on the screen for a while. So we can easily telnet in. It shows that kind of a nice echo response from a telnet server. Can we have the computer? Sorry. There we are. So we get a nice echo response from a device. The echo is just coming from the phone, so it's so we can see what it's doing. But it means that we can go back to slides. So now we've got a nice mechanism into the phone. The server is kind of the really nice part. It's the nuts and bolts that kind of drives Marionette and kind of gives us all the ins into the device and into the browser to be able to control it. The mechanism we're using is what we've called the JavaScript transport layer. It's just kind of a raw TCP into the browser, but we now can send JSON payloads through it. And it's got a few little extra bits and pieces added to it, which aren't too important at the moment, but it gives us this mechanism. It's being used at the moment by the remote debugger, which is part of Firefox. So like if you have an Android device with Firefox for Android, you can kind of connect your phone to a host computer and then debug from Firefox straight onto the device. It's the same technology as that. We're just kind of now using it for automation. We've created our own actor because it's an actor relationship in it. And the actor then receives all the commands that are coming through. It kind of breaks down what's in the JSON payload and then kind of decides where it needs to go. Normally, it goes through to a listener, and a listener attaches itself to all the content that's happening on the page. So like if you have multiple frames, a listener gets attached to each frame so that when we switch from frame to frame, we just can carry on executing. So where are we using it? We're currently using it on devices, emulators. We've got a special build of Firefox for Desktop called B2G Desktop. It's kind of got a number of all the instances, all the things that we need for B2G, minus hardware things. And we're using it on Firefox. It's now become, Marionette is now one of a tier 1 testing framework. So it kind of means that within Mozilla, if you push something into our repository and it breaks a Marionette test, it will be backed out and you kind of need to fix it. This is kind of how we view our test things. I know it's probably not going to be too viewable, but kind of on the left is commits grouped by pushes into our repository. On the right, I've limited the UI to only show the Marionette tests. That shows all the Marionette tests. So Marionette, and then hopefully by proxy Selenium, is now part of the Mozilla kind of waterfall. So every push that goes into Gecko now tests Marionette. It tests like the core parts of Marionette and then goes off and tests all the different parts that it needs to. And then in the center there, well, it's to the left of the Marionette part, kind of shows all the different platforms that we're running on. So we've got Linux, we've got Windows, we've got mobile devices. So we always know that Marionette's going to be there, and it's become so core to the way we do things. So how's it used? It's been retrofitted into a number of our test suites. As Malini said, we've got hundreds of thousands of tests, and like we need to test that things are working, because essentially Firefox OS is a browser on a device. We need to make sure that how people manipulate the DOM is still working properly. How people are rendering CSS is still working properly. Our reference tests are kind of important. And we need to make sure that like JavaScript and all these other little bits and pieces that are core to the way Firefox works still works on the device. Except we can't use the testing frameworks before. We just need to kind of make sure the tests work. And we're also starting to go into new bits, so telephony. It's kind of important for a mobile operating system to be able to make telephone calls. You know, internet is all great and all that, but people like to use phones to make phone calls for some silly reason. And then we've got this interesting part. a mobile device has got multiple parts to it that we need to make sure that we can access. So the browser needs to access these. And then from an automation and testing point of view, we need to be able to instrument them and test them. So there's different parts. There's GPS, there's Bluetooth, there's USB. There's all these different parts of the system, cameras, things like that. A browser needs to be able to speak to the hardware. The hardware goes, well, here's all the inputs that you want, and then we go from there. And we need to test all of this. So I'm going to show you a quick test on the computer. So this is just, it's going to run an emulator. Emulators, just by nature, are kind of slow. What this is going to do is this is going to run a geolocation test. It starts up in Emulator. It's going to set a number of different bits of information in the background to the emulator, then check it. It's going to be, yeah, in true emulator style. It's very slow. Runs everything. Hooray, and all our tests pass. But you can see it's set information, and then it's retrieved the information, checked everything's working. Back to slides, please. And then we also need to make sure that the UI is working. People need to make sure that they've got a functioning device, that if they go to make a phone call, if they go to set an alarm, they go to do all these things, those key parts of the system are working as they expect. They're working in a certain manner. But it's not just kind of making sure that Mozilla can make sure that the UI is working properly. OEMs who make the devices and are going to be flashing them for us, they're kind of strict on making sure that things work because it's kind of their name that's on the hardware when it goes out to people. So they want it to be of a certain quality. And for those who've kind of worked with iOS and with Android and have tried to kind of automate the UI and then kind of gone grey or gone bald because you pulled your hair out, we need to make sure that we give third-party developers who want to make apps a nice way to automate the UI if they need to, or if they just need to kind of execute different bits of code as they see fit. We give them that, because if you give them a nice kind of testing infrastructure, you kind of have a nice ecosystem that third-party people want to come. People want to build apps because they can prove that their app is of a high quality. So I'm going to kind of show you a test running on a device. If we can put it on this, please. Right. This is where I hope it works. So this test is kind of, if it wakes up the phone. Dun, 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 dun. Ah, the demo gods have struck.
There we go.
No, that's me. Let me show you how quickly the phone resets. While that loads, I'll get everything ready. Sorry for the technical delay. Right. Take two. Oh. What? Okay. Oh, that's why, because I'm... That look like it? Maybe not. Oh yes, all right. So kind of we try reset the phone between tests where possible because some parts we can't kind of clear out. So what it's doing is it's just going to set an alarm a few times and then kind of make sure everything's working. And I've broken it. Yeah, this was working earlier. Oh well.
I swear it totally was working earlier, right before the talk. But
yeah, okay, we'll just kind of skip the technical difficulties and we'll go back to slides. So kind of where we've been, a lot of our testing infrastructure we kind of had to be building on the fly as well. We just kind of started, because as Malini said, we were late to the game. We were invited late to the game. But we've had to play catch up very quickly. So we had Jenkins just running in the cloud, running our unit tests, our web API tests, so kind of the hardware part tests. And they were running them against emulators. Luckily, when we were at this stage, we didn't have hundreds of engineers working on Firefox OS. But then things changed, and we started getting more engineers, and more of the system started being built. And we needed to start running our unit tests, our web API tests, and our UI tests, because kind of we need to make sure that all the functionality is working. Gaia, which is a code name for the UI, needs to be working at a certain level. And we were running these on emulators, and we were running them on Panda boards. For those that don't know, a Panda board is just an Android development board. It allows us to kind of do some neat things. It's essentially just an XSS without a screen, and kind of looks like an Arduino or a Raspberry Pi. And then we went from there, and we started actually also testing on real devices. So we've got some devices that our OEM said was going to be of a similar ilk, and we started testing against those. And soon we're going to be testing against the devices that we're going to also be sending out to the public. This is what a rack of Panda boards looks like. It's a number of There's a number in there. This is a unit that was designed by our IT department, and it's a number of Panda boards. They've all got Ethernet. They've all got power. And what happens is, whenever a test is ready, we flash the device. It's got an SD card on it that we can change because SD cards only have a certain lifespan. We can swap out, it flashes the SD card, then we run our tests, and we go from there. One of the things mentioned earlier is that we also suffer greatly from flaky tests. Mobile is kind of one of those places where you're going to get a lot of flaky tests, and a lot of it also comes down to hardware. So one of the nice things about the Panda setup was we've got a framework called Mozpool, and we've got in our pool, we've got lifeguards who kind of check how things are going. If they notice that a certain board has an increase in failures, it starts taking that board out of commission, kind of lets someone know. And then we can just kind of hot swap the device, because this is just in a data center, so our IT department can go there, swap it out, and carry on. The other part of our test infrastructure is making sure that we can do stress tests against the device. Kind of just running and running and running and running tests, because people don't really switch off their phones nowadays. They go to bed with them on, wake up, and it's still running. And that's kind of the major use case that people are going to be using, and we need to make sure that the device doesn't become sluggish over time, it doesn't crash all the time, things like that. We need to kind of do all these really weird and wonderful stress tests. We started doing fuzzing over it with a tool called Orangutan, which was written by Will, who's in our team, which kind of just does gestures on the device at a very low level and then kind of sees what survives. And we started doing performance tests against devices. One of the important things that people want to be able to do is like play games. Most people play games on smartphones these days, so we want to make sure that if you're playing a game that you're kind of getting a high enough frame rate. We want to aim for that 60 frames a second, so that we can kind of make sure that it's not jerky, it's not anything like that. There's no jank, which is kind of where you try scroll and it stops for a bit and then carries on scrolling. We want to make sure that those things aren't there. And these types of tests mean that we can kind of make sure that when we deliver the device to people, to OEMs, and when third-party people want to start using it, they have their confidence in what we've done. And that's it, really. It's been a huge learning experience for our team. We've learned a number of weird and wonderful things along the way, and we've tried to solve a number of problems, and hopefully we've shared it up with you all. Thanks.
Great. Thank you, David and Malini. That was fantastic. I really loved that last picture there with the racks. I also learned the danger of calling APIs REST APIs, because sometimes your devices just take a rest. So, yeah. So with that, if you would like to ask a question, there's a mic in the back there and a mic over there. Feel free to grab the mic if you want to ask a question. And in the meantime, we'll grab one off of the moderator here. So first question up. How do you automate recovery for devices that fall off USB or get wedged outright during testing?
Okay, well, it depends on the device. So we have the Panda boards, which we can power cycle. And we don't use USB for them. We communicate over the network. Wedged outright during testing, I don't really understand what that means, but perhaps you do. But for other devices, we have to power cycle them. Like we have some tests using run directly against our phones, and we have to currently manually reboot them. But we have someone working on a solution for that right now, because manually rebooting them is just kind of not scalable at all.
Yeah, we kind of ask our manager to go, because we've got a kind of a big Faraday cage in our Mountain View office, and every so often we just ask our manager to go work in there for the day and just power cycle whenever we need to.
Yeah, so that'll be solved.
So you found a use for your manager. Perfect. All right. Looks like we had some questions. So I think you were up first, so ask away.
Sure. You touched on UI performance testing at the end there, but how do you what tools do you use to actually validate the UI performance? Do you have some kind of video recording, or people are watching it?
Yeah, so we have this tool called IDA-Ticker, and what that does is that it's just a camera that's focused on the screen, and it captures it and checks that the data is moving actually at 60 frames per second. So we have two ways of capturing that video data. One is to plug it in a video out cable directly to the phone and send it directly to our computer and analyze the HDMI output directly. And the other way, which is what we're experimenting with right now, is with high-speed cameras. And we're just making sure that each of the frames are changing at the rate at which we expect. Yeah.
Cool, thanks.
So follow on to that. So as you're sort of swiping or moving, one thing is the frame rate, but how do you actually know the animation is happening?
I don't know about the animation. But when it comes to swiping, one of the key things that brought us to doing this type of testing was when we rewrote a lot of the Firefox for Android stuff. When you scrolled, we were getting a lot of checkerboarding happening because the drawing wasn't happening fast enough. So we created a framework. Well, I say Will LeChance, who's on our team, he created a framework called IDA-Ticker, and that just kind of watches for these checkerboarding and then kind of works through that. He created Orangutan, which instruments Android and kind of tells it how to scroll and things like that. So this allowed us to kind of test against other browsers, so we could see how well we checkerboarded. Well, we don't want to checkerboard, but how other browsers were handling the same website.
Great. Second up, I think you were up. And if you want, you can say your name and where you're from and then ask your question. If you just want to ask, that's fine too.
Hi, I'm Daniel from Snap Interactive, and my question goes to security. Like, obviously, Marionette is a really great thing that allows you to drive everything about the phone, but what if someone were able to get access to that and do those kinds of things through your phone that you don't want them to do? How do you kind of prevent something like that from happening?
At the moment, Marionette is only available in engineering builds. So you kind of have to build it in to Firefox OS. We're working with our security team to kind of work out a nice way for developers to be able to have Marionette. So just kind of go in, buy a phone from your local phone company, and then kind of start working with it. Because yes, security is one of our biggest concerns. Privacy as well, because you know people might be doing internet banking on things like this, and we want to make sure that they feel secure, that they can do all these things, but also that if a developer goes and buys it, they can start working with it. So we've got a number of ideas, especially for desktop, how to sort the desktop problem. The mobile problem at the moment is just don't put Marionette on there, and then we'll kind of, as and when we can solve that problem, it'll start slowly being put back in.
Thank you.
Great, thank you. And another question over here, please.
Yeah, hi, I'm Jonathan from Sauce Labs, and if I recall correctly, you guys said that you, in your sort of WebDriver ++ protocol, you speak JSON over TCP rather than HTTP. So I'm wondering whether I, as a potential Firefox OS app developer, can use standard Selenium client libraries that already exist to speak to Marionette, or whether I have to base it off of something you guys have written.
So our Marionette client library is it's 90% the same as the Selenium library. We've got, like, ideally when we get to a certain place, what's going to happen is WebDriver's got an idea of like the commands that it's got, and then it's got a command executor. And what we want to try to do is just switch in the command executor for Firefox only, and then kind of it just knows to speak through that and then works.
Thanks.
It's worth pointing out that the spec mandates HTTP and JSON conformance.
And the spec also says that we have to do HTTP. We've already got a shim that people can use, but my gut feeling is that the Selenium project is probably going to be using straight into it, and then if you're not one of the languages that the Selenium project manages itself, you'll probably go through the shim. So we're still going to have that, and it's just essentially takes the HTTP, maps it down to our TCP connection, and goes from there.
So let me take a question from the moderator, so those that are watching live and remotely also get to ask some questions here. So I can throw this one over to Malini, I guess. Do you prefer to run on automated tests? Do you prefer to run your automated test on real devices or emulators?
Well, ideally we'd like to run on devices all the time, but that's also, we haven't solved the infrastructure problem of how do we power cycle these devices, and devices are very finicky. Emulators have been incredibly reliable as a way of testing, so we've been running all of our tests, like anytime you commit code to Mozilla, we run our tests against emulators just because they're easy to put up in VMs. It's like a very easy platform for us to use. And it's actually fairly representative of the environment that you're running in. So for most cases, emulators do just fine, but we do want to build out more device testing. So.
Okay, and last question, and then I'll do some announcements right after this question. So please, from the audience again.
This is Guam. I'm from Android Test Engineering. So from a mobile OS testing perspective, I think there's a lot of stack between what you're offering to the app developer down to maybe the kernel or the driver level. How do you solve the problem of poking the layers in between? Because from the presentation, a lot of the cases I've seen are mostly kind of like integration level or functional testing. Like how do you poke the levels in between? And also sort of in related to the question you just answered, there are device-specific characteristics or flakiness or problems. When you test mostly on emulator, how do you solve that problem?
for the first question, would you like to take that? I'll take the
Okay.
one. Yeah.
So for the first one, one of the things Malini mentioned during the talk was that we can set context and we can switch between different contexts within the browser. 90% of the time, what app developers are going to be using, well, actually probably app developers are going to use it 99.9%. They're going to be running everything in the content layer, which is kind of just your average web page. For what we're doing, we have frameworks like what we call Moki test and things like that. And what that does is that will speak through JavaScript into the Chrome layer, and then kind of it'll the best use case I can think of is how we test the DOM. A lot of the DOM stuff will be happening. That'll be happening in privileged space, kind of then pushes it out to the content space. And we need to make sure that when it manipulates it in a certain way, that we can then instrument it that way. So we just we can sit in the DOM, like in the Chrome space, the browser Chrome, and then just see what it's doing, ask it questions, and then get information back. We have access.
And with that, I'm going to let Malini have 10 seconds, and then you two can chat at lunch. So
Sure.
you get 10 seconds.
So for device-specific flakiness, on the emulator, we don't have we are able to distribute it to other people in our code and in our community, so that they can use it and test and make sure that it works in this environment. If it fails, then it's really up to them to fix those flaky problems. But when it comes to device-specific problems, you have to have the device on hand to resolve these flaky issues. And that's another problem, but that's why we rely on emulator so heavily as well.
All right, thank you. So.